Do you
Pascal's
remember
triangle.
what
Pascal,
we
yeah.
were talking about? Pascal's triangle, yep. And we were, I guess, getting ready to talk about how in the world is this going to be, how are we going to use this? So let's turn to example 10. And we are going to expand x plus 2 to the fifth. Now, every person in this room could do this problem because you know what it means. It means x plus 2 times x plus 2 times x plus, okay? It would take forever, be a bunch of foiling, but you could do it. It isn't hard, it's just very time consuming. So yesterday, we talked about how Pascal's triangle can give us the coefficients of the expansion. Remember when I did x plus y to the fourth on the board? And we observed that the coefficients in that expansion, 1, 4, 6, 4, 1, were actually a row of Pascal's triangle. So let's look at the triangle and remember how it's built. I know it's in your notes, but let's remember how it's built. Remember you add these. Remember how that works? So then the fourth row would be 1, 4, 6, 4, 1. And the fifth row, which is the one I want for this problem, would be what? What would the fifth row be? 1, 5, 10, 5, 1. Now, the triangle's in your notes, but it won't be given to you if you need it. This is not a huge deal, but it might be one multiple choice question on the exam. So you need to be able to build it yourself. So everybody knows how to build it? Okay, now, let's write down those coefficients. Because if I were to multiply this thing out, the coefficients would be these. Whatever your expansion is, whatever your binomial is, that power tells you which row of coefficients to get. So if that were 6, I would simply get the 6th row in the triangle. Everybody good with that? Okay. Now, next to each of these numbers, I want you to put the 2 pieces of the binomial. So in this problem, the 2 pieces are x and 2. So just put an x and a 2 next to each of your coefficients. Yesterday, when I was doing this, my 2 things would have been x and y. Because remember, I was doing x plus y yesterday. Now I'm doing x plus 2. Everybody with me? Now, if you remember from yesterday, what happened as I went from down the line, from term to term, what happened to the exponents on x? Do you remember? Look back at your notes. What happened when I did, if you wrote, I don't know, I told you not to write it down, maybe you did. X plus y, anybody write that down? No? Okay, I told you not to. So, just think about it. If you foiled this out all the way, just foil, wouldn't the biggest x be x to the 5th? And then as you go down the line, they decrease by 1. Till you get to the end, and finally it's a 0. So obviously, if you expanded this to the 5th power, the most you're going to have is x to the 5th. And then every term is going to decrease down the way. And then similarly with the 2's. Won't this end one be 2 to the 5th? If you multiply x plus 2, x plus 2, x plus 2, and then this will be 4. Couple of notes here. Anything to the 0 power is 1. So this is like not even there, and this is not even there. Second observation, look at, in each term, look at the sum of the powers. What do you notice about the degree of each term? The sum of the powers in each term. It's 5. Not a coincidence. It's 5. If we expand it to the 6th, it would be 6. They'd add up to 6. Now, these are individual terms, so I'm going to go ahead and separate it with plus signs. It's a little crowded in there sometimes, so we want to make sure we're keeping each term separate, and then we'll simplify. So what is this? What is that first term? That's all multiplication there. What does that just end up being? X to the 5th. Which again, just think about that for a second. If you FOILed this out 5 times, doesn't it make sense to you that you have x to the 5th? What comes next? Plus what? What's this going to be?
10x to the 4th.
10x to the 4th. How about this one? 40x to the 3rd. Good. Next? 80x squared. Another 80x this time. And then on the end, we'll have a 32. So you just multiplied x plus 2 times itself 5 times. Pretty simple, right? Pretty simple. Let's try the next one. This one is 2x minus 1 to the 4th. All right, so where do we start? What do we do first? Get your coefficients from the triangle. Which row of the triangle are you going to get them from? The 4. So 1, 4, 6, 4, 1. Then what? Put in your 2x and your negative 1. So 2x is one piece of the fact of the term, and negative 1 is the other one. So 2x and negative 1. Once you get your coefficients written down, next to each one, put the 2 parts of your binomial, which this time are 2x and negative 1. Okay? Now, what's next? Put in your powers. And you know that for the 2x, the first piece, the first power is going to be 4. And then it's going to go down. And then the second part, we'll do the same thing the other way. And you just kind of want to keep an eye on it, because you know that each term, whatever powers you put on there, they have to add up to 4. These are individual terms, so sometimes they start running together on your paper. Make sure you're keeping them separated. Now you're ready to simplify. So what do we got first? 16x to the 4th. Watch it. Now we're going to have a negative 32x cubed. You ready to get why that's negative? But now we're going to be back to positive. What? What's this on? 24x squared. Now we're back to negative again, negative 8x. And positive 1. That look okay? Pretty easy. It takes a lot of space, but it's pretty easy. And it beats the alternative, because that's a whole lot easier than foiling that out. Right? Especially if that power gets big. 12 is a little bit different. What is the coefficient of the term containing x to the 4th when the expression x plus 5 to the 6th is expanded? So this time, we're not looking for the whole line. We're looking for only one of the terms. So it's x plus 5 to the 6th. If we were doing the whole line, we were doing the whole thing, like we just got done doing, we would need the 6th row of our triangle. So we would need, what would that 6th row be? 1, 6, 15, 20, 15, 6, 1. And if we were doing the entire expansion, on this guy right here, the power on x would be 6. Would you agree with that? Here, the power on x would be 5. And here it would be 4. That's the term we want, because it says x to the 4th. Does that make sense to you? Just counting down. So I'm going to have a 15. I'm going to have an x to the 4th, but I'm also going to have a 5 to the 2nd, because those got to add up to 6. That's the only term I care about, right there. That's the only one I want. So when I simplify that, what do I get? What's 15 times 25? 375. So this term would be 375 x to the 4th. Everybody okay with that? Last one, number 13. What is the coefficient of the term containing x cubed when we expand this? Oh, shoot. I mean, this is an easy problem, but why am I saying, oh, shoot? What do I need to figure out?
You gotta go 8.
I gotta go to the 8th row. And there's no shortcut, because it's not like I can skip a couple rows and get here, because I'm getting them by adding what I already have. So the 6th row was 1, 6, 15, 20, 15, 6, 1. So the 7th row, don't let me make a mistake, and the 8th row. Does that look okay? Now, this time I want x cubed. So remember, what would the power on x be right here? 8, 7, 6, 5, 4. Is this the one I want right here, 56? 8, 7, 6, 5, 4, 3. So I'm going to have 56, x to the 3rd, and negative 3 to the 5th. Goodness gracious, negative 13,608 x cubed, is that what you got?
Yeah.
So it said, what's the coefficient? That would be negative 13,608. Huh?
Said I don't like this.
You don't like this? What part of that don't you like?
It's just a lot.
I think it's pretty easy, actually. But it is tedious if you have to keep doing this, right, Ben?
Got negative 13.
Oh, you got negative 13 what? Million?
Yeah. Yeah, that's millions.
Okay, so what's negative 3 to the 5th?
Negative 243
Okay, times 56.
times 56.
No, no
Oh,
X,
yeah.
no, no, just
That's
the numbers.
where I messed up. Quarter round.
So were you typing in the X cubed?
Yeah, I did. That's where I messed up.
So probably somewhere in your calculator, you or someone else has stored a value for X. So when you typed in X cubed, whatever that value that was stored, it was getting cubed and times it by all that. So we want just the coefficient, no variable.
Wait, are you not cubing the, like you do negative 3 to the 5th times 56, and then is that your answer? You don't
That's your
cube that?
coefficient. Coefficient's just the number, not the variable. It's the number in front of it. Okay? Now, suppose, this is not on your sheet, but I want you, this is, we need to know this. Suppose that we had a problem just like that, but instead of being x minus 3 to the 8, let's suppose we had to find the fourth term of 2x plus 3y to the 7th. Oh shoot. I think I can still see my 7th row on my dirty board there. So I would need the 7th row of my triangle. The fourth term would be 1, 2, 3, 4, I got 35. So I'd write down my 35. And then I would write down 2x and 3y. And then I gotta put my powers on. Well, remember, here's my row. Right here, the power on the x would be 7, 6, 5, 4. Now that 4 doesn't have anything to do with being the fourth term. It just so happens that when I count down, it's 4. Which makes this one what? 3. So now when you multiply, you have to multiply 35, 16, and 27. So now you do have 3 things to multiply. We didn't in our last problem, but we do now. So 15,120 x4y cubed, is that all right with everybody? All right, one more. I'm gonna leave these ones up here. Alright, that was my 7th row. I'm just leaving it up here because I want you to do something for me here. If I were you, I would be worried about your crazy old math teacher doing something like this to you. Because you do it, but why are you worried about that?
It's a lot.
It's a lot. It's a lot. Because you would need to find not the 7th row of the triangle, but the 20th row of the triangle. And that would be a lot. That would be a lot. So I'm going to show you something. Take out your calculators. I want you to press 7, the number 7, and then I want you to go to Math, your Math button. Click across the top menu to PROB, P-R-B, P-R-O-B, whatever it says, and click down to the button that says NCR. Press that, and then put another 7 and hit enter. What did it say? 1. Okay? Now, I want you to do the same thing. Do 7, math, go across the prob, down to NCR, and this time do 6. 7, NCR 6. What does it say? 7. So this was 7, C7, this was 7, C6. What do you think's gonna happen when you do 7, math, NCR 5? You get 21? The 7th row of Pascal's triangle are the 7 C numbers. The C stands for combinations. That's a huge conversation. Did you last year talk about combinations and permutations at all? Okay, so it's a huge conversation we're not gonna have today, but just know that the numbers in Pascal's triangle can be found with that C button, NCR button. If I wanted the 5th row, I wouldn't be doing 7C, I would be doing 5C. So if I need, for whatever reason, if I need the numbers in the 20th row, I can find them by doing 20C20, 20C19, 20C18. This is gonna take forever too, but usually, I don't need them all. Usually it's like this problem. Find the 4th term. The first coefficient is always, in this case, 20C20. 20C that number. So 18C18, 19C9, whatever it is. And then they count down just like the exponents do. So 20C19, 18, 17. So that guy right there would be my coefficient if I were doing this problem. You see what I'm saying? So I go to my calculator and do 20, math, prob, NCR, 17, and it's 1140. Now we're not done, because next to that 1140 is a 2x and the 3y. Remember, this is just the number out of the triangle. Okay? Now, what would the powers on these be? Well, here in the first term, that power would be 20, 19, 18, 17, which means the power on this would be 3. And now I'm going to multiply my 1140 times 2 to the 17th times 27. Oh my Lord, then you do get a big one this time. So 403, 439, 6160, x to the 17th, y to the 3rd. That would be the 4th term of expansion. Okay, so there's no probability in this class, unfortunately. That's one of the things they left out. But where do you find the numbers in Pascal's triangle? In the math problem menu, using the NCR button. Okay? Everybody got that? Okay. All right, let's look at the next page then. So you check your understanding. Do some graphing and stuff here. So here we go. We're on, check your understanding, and we're going to start by dividing. Could we do long division? If we wanted to do polynomial long division, could we? Yep. could we also do synthetic? Yep, and that's what I'm gonna do. You can always do synthetic when you are dividing by a linear binomial, so like x plus 3 or x minus 3, something like that. If it's something like that, no squares allowed, just a plain x, linear. So I put a positive 3 out here because that's a negative there. And so here we go. All right, I don't know, check my math there. How did I do? Is that okay? So what's my answer? It says divide. What's my answer? X to the second, because wasn't this x cubed? We're dividing by an x, so it's gonna go down one. So x to the second plus 5x plus 10. And then what's that? The remainder. Now, it didn't say find the slant asymptote, so I gotta include the remainder as part of the answer of the division problem. Any question about that, you guys? You're good? All right, now we're gonna find the slant asymptote. So basically, that's the same problem. I'm gonna do another division. What am I gonna put out here in the box? 2. Now I don't care about the remainder because I'm finding an asymptote. So y equals x plus 5 if I divide it correctly. How do I know that problem has a slant asymptote and not a horizontal asymptote? Exactly. Good job. The power on top's bigger. Remember, the power on top's bigger, you're never going to have horizontal asymptote. All right, let f of x equal g of x over x plus 4 for some polynomial. If x plus 4 goes into g of x evenly, describe what is happening on the graph of f at x equals -4. It's easy, you know, there's a lot of words there to sort through. What do you think? Watch it. G of x is your numerator. And you are told that g of x, or that x plus 4 divides into this. So that means x plus 4 has to be a factor of it. So I'm totally making that up. But that's what that means. X plus 4 divides into your numerator. That means it's a factor of the numerator. Well, if x plus 4 is a factor of the numerator, that means what's going to happen? You're going to have a hole. You're going to have a hole at -4. Now, we don't know where it is because I made this part up. I don't know what the rest of the polynomial is. But there's going to be a hole at -4. X equals -4. If x plus 4 didn't divide it evenly, then you'd have a vertical asymptote there. Okay, so go ahead and FOIL 4a. I'm not sure where this is going. Go ahead and FOIL that. So what is it? X cubed minus 6x squared plus 4x minus 20. Okay. Does that, question B, does that mean that x squared plus 4 is a factor of that?
Yeah.
Yeah. Didn't we use it to multiply to get that?
Yes.
So what would be the remainder if we did a division? 0. It's a factor. If you're a factor, your remainder is 0. All right, and then the last one, the whole back side there, we are going to figure this out. So you and your partner, see if you can answer these questions and sketch the picture. You're going to answer all the questions and sketch in whatever order you want. Sometimes I like to sketch first. shooty shooty. That thing doesn't factor, does it? This is new and exciting. Thoughts? Any thoughts?
Factor the top. Can you factor?
Doesn't factor. I tried.
Quadratic equation.
Okay. Oh, okay, wait, I'm hearing two great things. One thing I heard was do the division. All right, what information is this going to give me? Doing the division. It's gonna give me my slant asymptote. So hopefully, I divided right. I got 2x minus 3, but let me double check that. That's what you got too? Okay, I'm gonna go ahead and put that up here. That has a y-intercept at -3 and a slope of 2. So here's my y-intercept, 2 over 1, 2. All right, I'm gonna put in my, all right, there's my slant asymptote. All right, so I heard that. Is everybody okay with that? Do the division. Then I heard something about the quadratic formula. Because the top didn't factor, and somebody said, let's use the quadratic formula. Now, what would this be doing for me? Telling me my x-intercepts. This is gonna tell me where my x-intercepts are. They aren't gonna be nice whole numbers. In fact, we might not even have any. What happens? It's gonna be imaginary, so what does that mean? We're not going to touch the x-axis. Whatever's happening, you're not gonna cross the x-axis because your zeros are imaginary. You okay? This is freaky, we can do it. All right, what else are you thinking about? That should be common. Yeah, you're gonna have a vertical asymptote at x equals -4. Okay. Do we have a y-intercept anywhere? Do we cross the y-axis anywhere? No, that isn't a real point there. Where do we cross the y-axis? What's our y-intercept? Our y-intercept, put in zeros.
5/2.
5/2. Okay, we have no holes. We have no zeros, no x-intercepts. We've got our slant in there, and we have our vertical in there. Y-intercept. Any thoughts on what this looks like?
The upper part will, like.
Exactly. Now, I don't know exactly how far down it's gonna go. I'm gonna draw it like this. But it could get down lower and come up, I really don't know, but I'm gonna draw it like that. And it's gotta follow that asymptote out and that asymptote out, that's perfect. That is what happens on the right side of the picture. Can anybody tell me what happens on the left side of the picture? It's a little bit tricky because you can hardly see it, but right down here, this is what happens.
Did we just do that by plugging it in?
You could, but I didn't because, remember,
Oh, doesn't touch the X.
doesn't touch the x-axis and it has to approach its vertical asymptote. Remember, as you approach your vertical asymptote, you're gonna either shoot up or you're gonna shoot down. You can't shoot up, so it's gonna have to be shooting down. So let's answer the questions. Identify any holes or vertical asymptotes. No holes, but we have a vertical at -4. Explain why F, that's our picture, looks linear for very large values of X. So what that means is, as X gets bigger and bigger, as we go to the right, what is happening to our curve? It's getting closer and closer to this line. So why does it look linear? Because its slant asymptote is a line, and it's approaching its asymptote. How does rewriting a function in a different way reveal different properties about the function? Well, the only thing I can think of is factoring always helps us see like x-intercepts and all that stuff. I'm not sure about that, but we've got it drawn. All right, now we got some practice. Here we go. All right, so let's go ahead and do this practice. I'm going to give you a couple minutes to maybe get the front page done on your own. Take a couple minutes, see if you can get the front page done. I'll do it too, and we'll compare notes. A standard form just means multiply it out, so it looks like a normal polynomial. You feel like you can answer number 1, number 2, and number 3, I'd love to see it on the board.
I can do
1. All right, Fred's got 1. Anybody got 2 yet? Or have a plan on 2? Come on, be brave. Perfect, thank you, come on up. I'm gonna check and see if I got what Fred got. I agree with Fred. Does anybody have any concern? The only possible quibble I might have, Fred, is the y-intercept should be a point, so it would be 0, 8. But, we do that all the time. We talk about it just as a number. But yeah, that's perfect, beautiful. And she's working on number 3. And she says, no, it's not a factor, because when she did the division, she got a remainder. Does that make sense to you? What does it mean to be a factor? It means you divide into it. So she did the division. And if she'd have gotten 0 for the remainder, yeah, it would be a factor. She didn't, so it's not. Now, nobody did number 2, but if you understand number 3, then you understand number 2, right? Because if we are told that x plus 1 is a factor, doesn't that mean it should divide evenly into my problem? So we're gonna find out here. It sure does, goes in evenly, no remainder. Now, what's left? X squared plus 3x plus 2? What are the factors of that? X plus 2 and x plus 1? So remember, x plus 1 was also an original factor, so it must happen twice. And that means that the zeros, or the solutions, are -2 and -1, and that has a multiplicity of 2, because it happens with the original factor and with the new one. Is that okay? All right, turn it over. We got some of the same stuff going on. So, let's try the same thing. And this time, let's have some volunteers. I love those of you who volunteered. Thank you, thank you, thank you. Let's get some more up here. Number 2. Three's interesting. Notice number 1 doesn't ask you to multiply it all out. You don't need to. You could, but you don't need to. Unless you just love multiplying. factor. Somebody said no, gotta give the division and got a remainder. Would you agree with that? Number two? What, number one, what's the degree of that thing? Guys, we should know this. The degree of that thing is 4. And how do we find the y-intercept? Plug in 0, and what'd you get when you plugged in 0? Negative 24, yeah, 0, negative 24. Everybody okay with that? Okay, not sure why nobody did that. Now 3a, wow, that's a little wacky. Did you type it in?
Yeah.
And hit graph? What's it do? Does it cross the x-axis anywhere?
Yeah.
Okay, where did it cross the x-axis? At -1. So doesn't that mean that if it's crossing the x-axis at -1, if I divide -1 into here, I better get 0, right?
Wait, did you also get that across to 3?
Okay, wait a second. Okay, wait, I did something wrong. Oh, that's positive 6. So it crosses at -1. Everybody in agreement? But it also crosses at, where did you say? 3. So that means I'm going to take what I have left. I've already divided out the -1. And now I'm going to take what's left and divide out the 3. And sure enough, I got a remainder of 0. So this built a factor of x plus 1. This built a factor of x minus 3. Now this is what's left. What is that? What is left? This was x to the 4th. So after the first division, it became x cubed. So this is -1x squared minus 16, which is -1x squared plus 16. What are the roots of x squared plus 16? What happens when you set that equal to 0? What do you come up with? Imaginary? So you had a root at -1 from your calculator, you had another one at 3 from your calculator, and then you had 2 more from your algebra. Is that good news? Yeah. How many is that? 4? How many am I supposed to have? 4? What are my factors? Well, here are 2 of them. X plus 1, x minus 3. What would the other 2 be? X plus 4i and x minus 4i. Very, very good. Very good. All right, we got a little bit more of that to do. I'm gonna go ahead and assign that 1.11. We have a little more binomial practice to do. And then I'm gonna hand out I'll do that soon.